Now, class, the last lecture we discussed electric fields in matter. So let's continue the discussion today. This time we will talk about the electric displacement. Now, let's recall from last time that the bound volume charge density this is given by rho sub b equal to negative divergence of the polarization vector. Now, the bound surface charge density this is given by sigma b equal to polarization vector dotted with n hat, where n hat depends on your bounding surface. Now, let's introduce free charges. Class, take note, hindi ito equal sa bound charges. Free charges, parang tayo yung naglalagay nun. So, let's note that this is not a result of polarization. Now, let's label this as rho sub f. We note f for free. Now, class, the total charge density now is given by yung dati, yung bound charge density, tsaka yung inintroduce natin na free charges. So that is given by rho equal to rho sub b plus the introduced rho sub f. Now let's recall Gauss's law. Del dot E that is equal to rho over epsilon naught. So we have epsilon naught del dot E equal to rho. Now yung rho given dito sa taas, so we will get rho b plus rho f. Pero class yung rho sub b earlier, that is negative del dot p. So this is equal to negative del dot p, the polarization vector, plus rho sub f. Right ang epsilon naught del dot e. Now class, lahat nung may mga divergence, ilagay ko sa left hand side. So ito, ilagay ko dito sa left hand side. We will get divergence of epsilon naught e plus depolarization. That is equal to rho f. Now class, ito nilagay ko lang sa kabila ha. Then yung divergence, 'di ba? Ano 'yan? Can be distributed.
Ano yung polarization ulit, sir?
From last time.
Okay.
Yung polarization vector na in-introduce natin. 'Di ba? When you have matter, ganyan, na hindi na vacuum yung laman ng volume natin, may mga particles dyan, charged particles. Then, when you introduce an electric field, they rearrange themselves. So, ang tawag doon, polarization. Yung,
Okay.
kunwari, lahat ng positive nagre-reside dito, lahat ng negative nagre-reside dito. The material is polarized. Then, define yung degree of polarization nun by the quantity. Ito, yung polarization vector natin. Now, we call this quantity our electric displacement, D. So, this is from definition. This is your electric displacement. So now we have parang another version of Gauss's law. So that is del dot D equals rho F. So next page. So we have del dot D. That is rho F. Take note, F is for free charges. Class, di ba, this is parang similar to Gauss's law. We also have the integral form. So that is D dotted with dA equal to Q F enclosed. So this is the enclosed free charges. Sige, sulat natin. This is the total free charge enclosed in a volume. Okay, so class, ito lang yung important. This one and this one. So parang gumawa tayo ng bagong Gauss's law in dielectric media. So example tayo. Suppose we have a long straight wire. So a long straight wire with uniform linear charge density. Let's say lambda. This is surrounded by a rubber insulation. Di ba class, usually yung mga wire nyo, meron kang conductor sa loob, tas may rubber insulation sa labas of radius A. Now the question is find the electric displacement. So yun yung tanong. Now we have drawing natin. Nakang long straight wire. May charge density lambda. Surrounded by a rubber insulation. So kunwari ganyan. Meron kang rubber insulation dito. So cylindrical yan na may radius A. So this is radius A. Now, find the electric displacement. So what we will use here is the result from earlier, yung integral form. So d dot dA equals QF enclosed. So let's recall that integral ng d dot dA, that is QF enclosed. Now class, yung usual na method natin, Gauss's law. So let's make a Gaussian surface here, a cylindrical Gaussian surface. So ganyan siya. Na may radius S and may length, let's say L. L yung length niya. So class, ang d dot dA, that is given by d times 2 pi SL. Class, we know that the electric displacement, yung direction niya, pa ganyan. So parang Gauss's law lang actually. D times 2 pi SL, ang free and closed charge natin ay ito, lambda times L. So we have D equals lambda over 2 pi S. Now class, D is a vector. So ano ang direction niya? This is S hat. So parang lang class, sort of Gauss's law na parang nawala yung epsilon naught. Pero not all the time ganun. There are different cases. So kunwari, meron kang sphere, vacuum sa loob. Tapos may sphere, dielectric media. Tapos insulated ulit ng isang another dielectric media. So magkakaiba yung electric displacement sa mga region na yun. Now, let's go to boundary conditions. So, di ba class last time yung electric field natin may boundary conditions yan. Sa electric displacement din, we have boundary conditions. So, enumerate ko na lang. Similar lang naman siya dun sa electric fields natin. So, when you have a surface, kunwari ito, this is above, this is below. Meron kang electric displacement dito, meron kang electric displacement dito. So, the boundary condition 1, we have the electric displacement above minus the electric displacement below. That is the perpendicular component. So, bali ganyan siya. That is equal to the enclosed free charge density sa surface. So, sigma F. And number 2, di ba class last time meron tayong sigma over epsilon naught sa electric fields? So, parang nawala lang din yung epsilon naught dito sa electric displacement natin. So, number 2, the parallel component of D above minus the parallel component of D below, that is equal to the parallel component of the polarization above minus the parallel component of the polarization below. So, ni-write down ko lang yan. Class, medyo parallel naman siya sa ano, di ba? Electric fields. So, now let's move on to linear dielectrics. Now, class, gagamitin ulit natin yung polarization. So, define first the polarization vector that is equal to some constant times the electric field. Di ba, class, yung polarization natin, dependent siya actually sa electric field. Di ba, kunwari, meron kang material dito na may charged particles sa loob. Kapag nag-apply ka ng external field, depende sa lakas neto kung gaano mapopolarize yung nasa loob, di ba? Kung medyo mahina, siguro yung polarization medyo mahina lang. So, medyo magkakatabi pa yung mga charges natin. Pero kunwari, lakasan natin yung electric field. What happens is mapopolarize ng gusto yung sphere natin. So, meron ka ng negative dito sa extremities. Tapos may positive na dito. So, yung polarization nyo, dependent on the applied electric field. So, let's say siya ay linear. So, the polarization is a linear function of E, where this is some unknown constant. Now, let's write this as epsilon naught chi sub E times electric field. Itong some constant, naging ganito. Where actually, this is your epsilon naught, yung permittivity in vacuum. Yung chi, Greek letter chi ito. This is your electric susceptibility. So, ito ay dimensionless. Now, let's label this equation star. Now, materials that obey the equation star are called linear dielectrics. So, ganun lang. Kaya siya linear dahil linear yung dependence niya sa applied external field E. Now, class, in linear media, so linear dielectrics yung pinag-uusapan natin, let's recall that the electric displacement is epsilon naught E plus the polarization. Diba? From the definition of the electric displacement. Now, this is given by epsilon naught E plus, ano yung P natin? Epsilon naught chi EE. So, factor out natin yung E. That is epsilon naught 1 plus chi E. times C. Now, this whole term, we define this as the epsilon, or the permittivity of the material. Okay, class. Epsilon naught, permittivity ng vacuum. Epsilon, permittivity ng material. So now D is defined as epsilon E. Now class, di ba medyo mas simple yung ganitong form? This means that in vacuum, D is equal to epsilon naught E. Or in some linear media, D equals epsilon E, where E is the permittivity of the material. So take note that epsilon equals epsilon naught in vacuum. Now class, let's define, puro definition tayo. The relative permittivity. Or we also call this the dielectric constant. So medyo familiar siguro yung term na dielectric constant. So this is given by epsilon naught R, R for relative permittivity, defined as epsilon over epsilon naught. This is also equal to 1 plus chi E. Diba ito? Ito, divide mo ng epsilon naught. Ang matitira, 1 plus chi. So yun lang. This just measures the ratio of the permittivity. So example, vacuum, epsilon R is 1. Tapos the rest, epsilon R actually greater than or equal to 1 kasi parang wala nang mas bababa ata sa vacuum. 'Di ba? This one is greater than or equal to epsilon naught. Kasi parang epsilon naught yung lower bound mo. So actually, epsilon R is greater than or equal to 1. Now, example tayo. Suppose meron tayong metal solid sphere of radius A. Carries a charge Q. Now, it is surrounded out to radius B by a linear dielectric material. Let's say may permittivity epsilon. So of permittivity epsilon. The question is, find the potential at the center of the sphere. So class, this is relative to infinity. Di ba class, ang dami nating parang, ano ba yon? Dami nating ways to find the potential, di ba? So here, ang gagamitin lang natin yung pinakasimple, yung nag-integrate tayo, yung E.dl. Now class, bakit hindi pwedeng gumamit ng Laplace equation dito? Dahil meron kang charge Q. Di ba yung Laplace equation del squared V equals 0? So dapat 0 yung charge density mo. Pero here, meron kang charge. So hindi pwede gumamit ng Laplace equation. Now, the first step, find the electric displacement. Ano ba itsura nung natin? System natin. Meron kang metal, solid sphere, radius A. na may charge Q. Tapos, so lagay ko Q. Now, surrounded siya out to radius B. Out to radius B. By some, linear dielectric material of permittivity epsilon. So, may epsilon ka dito sa region na to. Yung region na yan. So, the question is, find the potential at the center. Dito. Now, to find the electric displacement, recall natin that d dot dA, that is Q, F, and close. Now, kuha tayo class ng Gaussian surface outside. Now, this is given by, let's say, some radius r. So, di ba, mag-Gauss's law lang tayo. So, therefore, d times 4 pi r squared, yung area ng sphere natin, that is equal to, ano class yung enclosed charge netong Gaussian surface? So, lahat, di ba? So, Q. So, bale, d equals Q over 4 pi r squared. Ang direction nito ay r hat. Take note, this is at r greater than b. Now, class, take note, in vacuum, d equals epsilon not e. So, we have e equals, previous tayo, i-divide lang natin ng epsilon not yung d. So, this is 1 over 4 pi epsilon not. So, q over 4 pi epsilon not r squared r hat. So, parang yung usual na electric field natin. Next, in the material. A is less than R, is less than B. So, nasa gitna. So, titignan natin yung region na to, yung in the material na. We have D equals epsilon E. Diba? Kung vacuum, D equals epsilon not E. In the material, D equals epsilon E. So, bale, E now is equal to Q over 4 pi epsilon R squared R hat. Take note, in vacuum, epsilon naught. In the material, epsilon. So, meron na tayong dalawang region. Yung vacuum sa labas, yung dielectric material, and syempre, yung sa loob ng sphere. Now, class, in the metal sphere, ano ang electric field natin? Dito sa metal sphere sa loob. Anyone?
Wala.
Yes, wala. 'Di ba? Kasi charges reside on the surface kapag conductor yung material mo. So, electric field is 0. Ayan. So, meron na tayong electric field for the 3 regions. Dun sa vacuum sa labas, eto, yung sa material, tapos yung sa loob. Now, we can find actually the potential. So, next. So, recall natin, B equals, V, rather, negative infinity to 0, E dot dl. Class, ito yung unang way natin, di ba, to find the potential. Since we know the electric field, we can find the potential. Now, since magkakaiba yung value ng E sa bawat region, i-divide natin yung integral sa tatlo. So, bali, negative infinity, ano yung unang boundary natin? B, E dot dl, plus negative B to A. This is B to A. E dot dl plus negative A to 0. E dot dl. Now, this is equal to negative infinity to b. Ano yung electric field natin in vacuum? Q over 4 pi epsilon naught r squared. Q over 4 pi epsilon naught r squared r hat dotted with ano yung DL natin? So, DRR hat yan, di ba? So, bale, DR na lang to. So, ayan. Minus A to B ng Q over 4 pi epsilon r squared. DR ulit. Minus 0. Kasi 0 to. Electric field inside. Now, this is equal to Q over 4 pi epsilon r. Tama? Kasi over negative 1. Tapos may negative ka dito. Magka-cancel yon. Evaluated from b to infinity plus q over 4 pi epsilon r squared. Ay, r. Evaluated from a to b. Now, this is equal to q over 4 pi epsilon naught b. Tapos yung infinity, mawawala kasi magkakaroon ka ng over infinity dito. So, 0 yung second term mo. Plus q over 4 pi epsilon b minus q over 4 pi epsilon a.
Sir,
Yes.
bakit A to B nga yung limit nung sa second integral? B to A siya nung una.
Ay, oo nga. I see. So, kaya pala mali. So, B to A. So, B to A, palitan na lang. So, this is B to A. So, bali magkakaroon din ng change dito. Kaya, thank you for pointing out. 4 pi epsilon A, 4 pi epsilon B. So, bali, ang potential natin, that is now equal to Q over 4 pi. Factor out ko lang yon. 1 over epsilon naught B plus 1 over epsilon A minus 1 over epsilon B. This is the value of the potential at the origin. Now class, ano to medyo, siguro sa tingin nyo, papalitan ko lang yung epsilon naught ng epsilon, di ba? Pero in this result, parang medyo magkakamali kayo kapag ginawa nyo yun because madali lang naman kumuha ng potential in dielectric media, pero you need to do the steps hindi yung epsilon naught papalitan nyo ng epsilon for the media kasi baka magkamali kayo doon. So pero yung essence nun parang ganun, yung epsilon naught naging epsilon in linear media.
Sir, question po.
Yes.
Sir, yung D po, lagi pong buong surface, parang buong material, yung Gaussian, ano niya.
Yung
Yung
D
sa
ito.
D po, opo. Buo po
Actually,
lagi.
pwedeng sige, kunin natin yung D sa gitna. Okay, sige. Kunin natin yung D sa gitna. 'Di ba? Ano ang close and charge and close charge mo? 'Di ba? Q din. 'Di ba? Kasi na-enclose mo tong buong Q neto. So bali same lang yung electric displacement mo. So meron na tayong region outside, meron na tayong region in the middle. Now, kunin naman natin yung D region sa loob. Ang enclosed charge mo sa loob ay 0. So ang D mo ay 0 sa loob. Parang electric field lang din siya in a sense. Kaso dito, nagmo-multiply ka ng epsilon naught. Sa loob, nagmo-multiply ka ng epsilon. Tapos electric field mo is 0 sa loob. Therefore, the electric displacement is also 0 sa loob.
So sir, so tama ba intindi ko? So essentially, Yung dielectric media is parang material where mas mababang electric field. Parang ganun.
Yes. Yes.
And so, yung electric displacement is just Gauss's law, pero accounting for mga mga dielectrics, parang ganun.
Yes.
Okay.
Now, actually yung electric displacement, mas general siya kaysa electric field. Tignan nyo dito. 'Di ba ang electric displacement ay this one in vacuum. In the material naman, D equals this. So once you get the electric displacement, kaya nyo lang makuha actually yung electric field ng kahit anong medium man yan. I-divide nyo lang ng epsilon yung electric displacement. Again, D independent of the material. Sige. D over epsilon equals C. So, di ba ganyan? Or D equals epsilon E. Ito, independent of the material. Tignan nyo. Wala tayong term na epsilon dito, di ba? Or epsilon not. Electric displacement lang siya. Now, yung electric field, doon napapasok kung epsilon or epsilon not or whatever permittivity yung meron ang material nyo. Okay? So, may tanong pa? Wala na. Okay. Now, let's move on to boundary conditions. May boundary conditions na tayo nung una, di ba? Meron ulit tayong boundary conditions. Kanina, electric displacement. This time naman, the potential. So, suppose meron tayong bounding surface dito. This is epsilon above, material above. This is material below, epsilon below. Meron kang potential above, meron kang potential below. So, ganyan. Di ba? Usually, di ba dati, vacuum to. Puro epsilon not lang yan. Now, i-generalize natin. So, at the boundary, meron tayong first condition, epsilon above, partial V above, partial N, minus epsilon below, partial V below, partial N. That is equal to, evaluated at the surface pa pala. That is equal to negative sigma F. Where this is our enclosed free charge. Ano may sinasabi ko? Free surface charge density. Now, that is condition 1. Di ba, parang ito yung discontinuity ng derivative sa potential. Generalize lang natin, naglagay lang tayo ng mga epsilon. Di ba, ito, yung dati, sigma over epsilon not yan. So, yung epsilon, dinistribute natin dito. Naging epsilon above. Tapos ito, epsilon below.
Surface free charge yung sigma?
Yes. Di ba dati, sigma over epsilon not yung right-hand side? Ito naman, free surface charge density. Actually, this one, magiging result siya ng polarization natin. Later on, makaka-encounter tayo ng example nito. Diba ito ay P dot N hat? Tama ba? So, yun siya.
And isa pa sa yung N, that's the normal to the surface.
Yes. So, depende ulit sa sa system nyo. Kung sphere, edi N equals R. So, kung cylinder, kunwari ganyan. So, N equals S. So, depende kung anong coordinate system kayo nag-work. Now, first condition, discontinuity ng derivative. Second condition, continuity ng potential. So, V above at the surface is equal to V below. at the surface. Parang ganun lang din yung una. So, first, discontinuous ang derivative. Second, continuous ang potential. Sige, example tayo. Suppose, sphere ulit. So, a sphere of homogeneous dielectric material is placed in a uniform field. Let's say E naught, E naught ZZ hat, E naught ZK hat. Ayan. The question is find the field inside the sphere. Ay, sorry. This is E naught K hat. So, constant lang yan. So, ano natin? Drawing natin yung system natin. We have ano to? Ganyan. Then, meron tayong electric field. Uniform electric field outside. So, ayan, expose siya sa electric field na may value na E naught K hat. So, let's say, ano to? Merong radius R. Now, the question, class, is, kapag na-expose ba ang matter sa electric field, anong mangyayari dun sa electric field inside the matter? So, kunwari kayo, na-expose kayo sa electric field, anong mangyayari sa electric field sa loob ng tao? Parang ganun. Now, to do that, actually, we will use Laplace equation. Bakit? No charge. Rho equals 0, di ba? Pwede tayong gumamit ng Laplace equation. Now, boundary conditions muna tayo. So, 1, V in equals V out at R equals R. Number 2, epsilon. Ay, nakalimutan ko pala lagyan ng epsilon to. Kunwari may dielectric, constant na epsilon. Homogeneous dielectric material, epsilon. So, epsilon partial V in, partial R. Class, tignan nyo yung boundary condition natin. E above minus E below at the surface equals negative sigma. Now, E above, that is vacuum pala. Di ba vacuum yung above? Epsilon not yung above. Tas epsilon yung loob. So, epsilon not V out pala to. Minus epsilon partial V in partial R. That is equal to 0. Now, class, baliktarin ko lang to. So, epsilon partial V in partial R minus epsilon not partial V out partial R. That is equal to 0. Bakit? Wala kang nilagay na sigma at the surface. 'Di ba? Wala kang nilagay na free charges dito sa labas. So, kung kunwari yung problem, naglagay ako ng sigma equals something. So, ilalagay nyo yun sa right-hand side. Pero here, sigma F is 0. Pero class, meron ba tayong third condition? At R, much greater than the radius, electric field equals E naught K hat. Bakit? Ito, yung nilagay natin. Meron tayong uniform field everywhere. Tapos, at very far distances, yung value ng electric field ay E naught K hat pa rin. So, ilalagay natin yun as a third condition. At great distances, the electric field is E naught K hat. Now, class, ano ang potential na nagpo-produce ng ganitong electric field?
Linear?
Negative E naught C. Bakit? 'Di ba E equals negative del V? Ano ang negative gradient nito? Negative partial Z ng negative E naught K hat. So, bali, this is E naught K hat. So, ang potential na to, ang nagpo-produce ng electric field na ganito. So, yan yung potential natin at very far distances. So, at R equals R. At R much greater than R. Now, we have three boundary conditions. Class, huwag kayo malito dito sa pangatlo. Di ba dinagdag natin to? Usually, dalawa lang yung boundary conditions natin, di ba? Continuity of the potential, discontinuity of the derivative. Pero kasi, yung pangatlong condition, may nilagay kasi tayong external field outside. Kung wala yan, dalawa lang yung boundary conditions natin. Pero since naglagay tayo nito, we need to include that here. Now, recall natin yung usual na Laplace equation. Teka lang. I can also write this as negative E naught R cos theta. Di ba ang Z, yan ay R cos theta. In spherical coordinates, meron kang R. Yung R vector yan ay X. Sorry. Tapos, yan ay may magnitude na R, tas ito ay theta. Tapos, itong Z, that is R. Ito, R cos theta. So, kaya, pwede siyang isulat as this one. So, let's call that V in of R theta. That is equal to L equals 0 to infinity. Plus, lahat ng previous lessons, nagagamit ta. R to the L. Actually, hanggang sa dulo ng 130, magagamit lahat nitong inaaral natin. So, V out of R theta. Ito naman ay BL over R to the L plus 1 PL of cosine theta. Pero, meron pa tayong isang potential. Di ba at infinity class, nagva-vanish to? Zero to. Actually, meron pa tayong minus E naught R cos theta. Bakit? Kasi class, dito na papasok yung third boundary condition. At R approaches infinity, let's say ito, the potential must be equal to negative E naught R cos theta. So at R approaches infinity, mawala to. So matitira, E naught R cos theta. So dito na pumasok yung third boundary condition natin. Now let's use boundary condition 1. So ano yan? At the boundary, so R equals R. R to the L. So that is equal. Mag-shortcut na ako class R to the L plus 1. Diba, usually meron pa tayong summation dyan, tapos may PL, tapos may summation din dito, tapos PL. Pero marami naman na kayo na-encounter na ganitong problem. So, shortcut na tayo. Minus E naught R. Ayan, that is for ano ba to? Boundary condition 1. Now class, bakit pala bakit E naught R cos theta? Wait nga lang. Maglagay na lang ako ng PL cos theta dito para hindi kayo malito. Summation PL cos theta minus E naught R cos theta. Now class, from inspection, anong L lang yung matitira dito? Diba, this is from L0 to infinity. L0 to infinity. Anong L lang class yung matitira dyan? Actually, the only valid value for L is L equals 1. Bakit? Ito class yung nagdi-dictate. Meron kang cosine theta dito sa term na to. So, bali dapat meron kang cosine theta only dito sa term na to at cosine theta only sa term na to. Now, lahat ng yon ay masasatisfy kapag L equals 1 for this one and this one. Plus, bakit hindi pwedeng L equals 2? Di ba yung L equals 2, cosine squared? So, cosine squared, tas cosine. Hindi pwede. So, dapat dependent lang to sa cosine, dependent sa cosine, and dependent sa cosine. Therefore, L is 1. Now, we have AL R to the L. So, P1 of cos theta is cos theta equals BL over R to the L plus 1 cos theta ulit minus E naught R cos theta. Now, we can see that pwede mag-cancel tong mga to. Tapos, we can write, B1 na pala to. Sorry. So, this is 1. This is 1. So, A1, R to the 1, cos theta. That is B1 over R squared, cos theta. Therefore, we get B1 that is equal to A1 R cube minus E naught R cube. Bakit? Kasi nag-multiply tayo ng R squared, both sides. So, R cube plus R cube. Now, ayan, yan na yung first condition natin. Express B1 in terms of A1. Now, next. We have BL. So, i-generalize na lang natin. A sub L R to the 2L plus 1. For L not equal to 1. I-write lang natin yan. Yan yung usual class na result natin. Now, let's look at boundary condition 2. That is epsilon summation L equals 0 to infinity. L, AL, R raised to L minus 1. PL of cos theta. That is equal to negative E naught cos theta. Kasi, di ba class, nag-partial derivative na tayo. Therefore, yung E naught R cos theta, naging E naught cos theta. Minus summation, L equals 0 to infinity. L plus 1. BL over R raised to L plus 2. PL of cosine theta. Now, at A equals 1, syempre, makakount tong term na to. Bale, we have epsilon 1, A1 that is equal to negative, syempre may cos theta ka dito. P1 of cos theta. Negative E naught cos theta minus 2 B1 over R cube cos theta. Now, balik class, we have, ano to? Mawawala yung cos theta. So, B1 bale, isolate natin. That is equal to, teka lang, negative epsilon A1 R cube over 2 minus E naught R cube over 2. So, yan. Ito, nilagay ko doon. Ito, nilagay ko dyan. Para ma-isolate yung B1. And for A not equal to 1, bakit A equals 1? This is L equals 1. For L not equal to 1, we have epsilon L, AL, R to the L minus 1 equals negative L plus 1 BL over R raised to L plus 2. Now, bale, BL, that is equal to negative epsilon L L plus 1. Tama ba? So, BL ay, so L over L plus 1 pala. L over L plus 1. A sub L R raised to L plus 1. This is for L not equal to 1. Now, class, next. For L equals 1, we have B1 that is equal to A1 R cube minus E naught R cube. So, A1 R cube minus E naught R cube. Tapos, meron din tayong isa dito, which is B1 equals negative epsilon A1 R cube. So, B1 equals negative epsilon A1 R cube over 2 minus E naught R cube over 2. So, bali, ano to? System of equations. So, ang gagawin natin, i-minus ba natin both sides? Ay, hindi, equate na lang natin itong dalawa. So, this one, equal dito. So, A1 R cube minus E naught R cube equals negative epsilon naught A1 R cube over 2 minus E naught R cube over 2. Bale, isolate natin yung mga A1. So, A1 times, lahat ng R cube, i-cancel na natin. So, A1 times 1 plus epsilon naught over 2. Tama ba? Epsilon naught ba yun? Second condition, U A1 R cube. Epsilon lang pala to. Ay, kakamali ako. Epsilon. Epsilon. That is equal to E naught minus E naught over 2. So, ito ay negative, wait lang class. Plus. Parang may mali ako sa algebra class. Wait lang. So, this is minus B1. Okay. Class yung B1, ito mapupunta dito. So, magiging positive siya. Ay, nako. So, that is, magbabago din to. So, magbabago to. May negative. So, this is equal to negative 3 halves E naught. So, balik class ang A1 natin. That is equal to negative. No, class, saan equal to? That is 2 plus epsilon over 2. Diba? So, bali, A1 is negative 3 halves E naught times 2 over 2 plus epsilon. Now, this is equal to negative 3 E naught over 2 plus epsilon. That is your A1. So, saan equal ang B1? Any of these two pwede nating gamitin. So, next page tayo. B1. Ito na lang. A1 R cube. So, negative 3 E naught over 2 plus epsilon R cube plus E naught R cube. Bale, ito ay kaya ba itong i-simplify? E naught R cube. Negative 3 over 2 plus epsilon plus 1. Now, this is E naught R cube times negative 3 plus 2 plus epsilon over 2 plus epsilon. So, ayan, nag-multiply lang ako dito. So, this is equal to E naught R cube times 1 plus epsilon. Ay, epsilon minus 1 over epsilon plus 2. Now, that is for A1 and B1. So, for L, not equal to 1 naman. So, yung the rest, we have BL equals AL R to the L plus 1. AL R raised to 2L plus 1. That's the first condition. Yung second naman, we get BL equals kalimutan ko. Negative epsilon L over F plus 1. AL R to the 2L plus 1. Class, sige, by inspection na lang to. Saan pwede ma-satisfy itong dalawang condition na to? So, bale dapat ito equal dito. Diba?
A sub L is 0.
So, yes. Actually, nasa-satisfy lang siya if AL equals 0 for all L not equal to 1. Yan lang class yung makakasatisfy sa equation na to. Kasi ito, meron kang extra term dito, di ba? Tapos yan, equal sa 1, di ba? So, that is only satisfied when L equals 0, AL equals 0 for all L not equal to 1. Therefore, BL is also 0 for all L not equal to 1. Actually, sinabi ko na ata yun kanina. Kasi dito, di ba, mapapansin nyo dito, meron kang cosine theta na extra term dito. So, lahat ng may cosine theta lang yung mabibilang nyo. That is L equals 1. The rest, 0 na siya. So, pinakita ko lang. Actually, kaya ko to sinulat. Para makita nyo na this one is satisfied for all AL and BL equal to 0. Now we can write the potential. V of r theta now is equal to A1 r to the 1 P1 of cos theta. Now plus ano ba 'yon? So V in pala. So yan lang 'yon. That is equal to ano yung A1 natin? Negative 3 E naught over 2 plus epsilon. R cos theta. So yan. Actually, class lang, yan lang yung gusto nating hanapin, di ba? The question is, find the field inside the sphere. We know the potential. We can get the electric field. Actually, class, this is also equal to 3 E naught over 2 plus epsilon. Ano class yung r cos theta? That is Z. Again, di ba? Yung pinakita ko kanina. Ito. Yung r cos theta ay Z. Now, class, E equals negative del V. So, ano to? Negative partial Z ng negative 3 E naught over 2 plus epsilon C. So, class, saan to equal? So, okay, hat. 3 E naught over 2 plus epsilon. Okay, hat. Yan na yung electric field inside the sphere. Now, class, ano yung system natin kanina? Di ba ganyan? Epsilon. May electric field ka. Ano to? E naught kay hat constant. Now, class, itong electric field na to, first, aligns with the direction of the applied field. Positive k hat. Take note, positive k hat. So, bali yung electric field ng matter mo ay nag-a-align dun sa external field na in-apply mo. Tapos next, what if, ano ba to? Wait, ba't parang mali yung dimension? Tingnan nyo to, class, 2 plus epsilon. So, class, sorry. Kalimutan ko isulat. That is epsilon r. Dapat dimensionless siya. So, epsilon r. So, class, lahat ng epsilon, gawin yung epsilon r. Kasi dimensionless dapat siya. So, epsilon r. Given lang naman yan. Nakalimutan kong sulat. So, this is epsilon r. So, yun yung dielectric constant niya, epsilon r. Anyway, so epsilon r. Kasi diba yung dimensions dapat nito, dimensionless. So, siya ay epsilon r. So, epsilon r. Anyway, so epsilon r. Now, class, meron tayong dielectric constant na epsilon r, di ba? Ano yung sabi natin? Ang dielectric constant, asan yun? Ay yung fraction ng epsilon to epsilon naught. So, bali kung vacuum, epsilon r is 1. Di ba? Kasi epsilon naught over epsilon naught. Now, what if vacuum yung material natin sa loob? So, epsilon r ay 1. So, bali ito, 2 plus 1, 3. So, 3 over 3, 1. Actually, class, kung vacuum yung loob, ang electric field mo ay E naught k hat. Yung value ng electric field outside. Tapos, parang nababawasan lang siya in a sense. Kasi, meron kang material sa loob na hindi na vacuum. So, ang effect niya, ito. may factor ka na 3/2 plus epsilon r. Okay, class. May tanong ba?
Patingin po ulit, sir, nung magiging potential equation given epsilon r dapat.
So, magiging epsilon r din to.
Epsilon r talaga siya dapat. Sa ano? Sa
Kasi relative permittivity na yung pinag-uusapan natin. So, dielectric constant siya. Dielectric constant. Epsilon r.
sa boundary conditions pala dapat, yung sa epsilon above minus epsilon below, relative epsilon yan sa boundary condition.
Wait. That is relative. Yes, ito. Relative siya. Ay, wait.
Pero parang epsilon not. Parang epsilon not yung isa yung sa
Yes.
epsilon.
Dimensionless siya.
Dimension ng epsilon not?
Ay, hindi. Wait nga, nalilito din ako. Sige, wait lang. So, dapat ito. From this condition, mali yung dimensions, di ba? Oo nga, no? Sige, balikan natin yan.
Equation ng epsilon not, siguro. Epsilon over kaya naging epsilon r.
So, nag-divide tayo ng epsilon not dito.
Kaya naging epsilon r siguro. Hindi kaya.
So, mawawala to.
Maybe.
Yes. Sorry. Nalito na ako. Medyo sabaw ako. Now, this is, sige. Sabihin natin na, ano ba to? Epsilon not, epsilon. So, mag-divide tayo ng epsilon not both sides. So, epsilon not. Sorry class, medyo sabaw ako. So, magiging ano to? 1. So, magiging epsilon r to. So, ano yung partial V out natin? Partial V out. I see. Okay. So, tama. Dapat correct yung dimensions. So, first, sige mag-umpisa tayo dito. Ayan siya, di ba? So, boundary condition. Burahin muna natin lahat. So, that is, ano ba to? Epsilon not. So, correct yung dimensions nito. Now, mag-divide tayo ng epsilon not both sides. Ay, nalilito na ako. So, ito magiging epsilon r. Ito, magiging 1. So, consistent na yan. Kasi, later on, yung V out natin, yung partial V out, partial r, hindi na pala ako naglagay ng, wala nang epsilon not dito, di ba? 1 na lang yan. Nag-multiply ako ng 1. So, yeah, thank you for the correction. So, dito, ito yung tamang boundary condition. Epsilon, tapos epsilon not. Pero mag-divide tayo ng epsilon not both sides para makuha yung epsilon r. Medyo clear ba?
Okay. Yeah, clear. So just wanted to clear that. Thank you, sir.
Okay. Ako rin na-lost din ako. So, okay, para hindi nyo magawa yung mistake ko, tignan nyo yung dimensions. Ang epsilon not, ka-dimension niya ang epsilon. Pero ang epsilon r, dimensionless. So, dapat ito dimensionless din to. 1. Anyway, buti hindi nag-cascade yung error. Kasi 1 to. 1 lang yung factor niyan. Wala nang epsilon not. Okay, other clarifications? Wala na. Okay, let's move on to energy in the electric systems. Now, recall natin class yung work or energy needed to, ano ba to? Assemble the charges. That is the Q, the charge. Potential from your initial position B minus the potential from your initial position A. Diba? Tas usually infinity to. Anyway, for a point charge dq, ang dw bale equals vdq. Parang ganyan. Now, let's recall yung definition nyo ng capacitance class. C equals Q over V. So, alalahanin nyo yan. V equals Q over C. Actually, ay, small q na lang. Small q. V equals Q over C. Now, class itong V na to, pasok natin dito. So, we get dw, that is Q over C. Ano to? dq. Now, the total, that is integral ng Q over C dq. Pero class, yung total mo, ay yung charge differential mo dq, di ba? So, yan yung bounds ng integral mo. This is from 0 to your total Q. So, we get W equals 1/2 Q squared over C. 1/2 Q squared over C evaluated from 0 to Q. So this is 1/2 Q squared over C. Pero take note that definition ng capacitance, Q over V, or Q equals CV. Therefore, Q squared equals C squared V squared. Now, this is 1/2 C squared V squared over C, or the work or the energy. This is given by 1/2 CV squared. Parang familiar naman to, di ba? 1/2 CV squared, yung energy ng ano mo, capacitor mo. Pero class, ang ginagawa kasi sa laboratory, yung capacitor mo, di ba initially vacuum yung pagitan nun? Nilalagyan nila yan ng dielectric material para mas maraming energy na ma-store. Now, gawin natin yon. So, for the material, let's say na may dielectric. Yung capacitance mo actually nagiging epsilon R. Take note, dimensionless ang epsilon R. Capacitance sa vacuum. So, yung original na capacitor mo na vacuum yung laman, magmumultiply siya ng epsilon R kapag naglagay ka ng dielectric material. So, ito na yung bagong capacitance mo. Now, class, take note. So, bale, di ba yung epsilon R greater than or equal to 1 yan? So, bale, nag-i-increase yung capacitance mo as you put dielectric inside the capacitor. So, the energy stored in an electrostatic system and that is given by, di ba, 1/2 epsilon naught E squared d cube x. Yan yung usual na na-derive natin last time. where E squared equals E dot E. Now class, for dielectric field capacitors, so for dielectrics na lang, the energy that can be extracted is given by 1/2 given by integral d dot E d cube x. So yung isang E mo napalitan lang ng electric displacement. Now yan na ang ano natin. Energy in dielectrics. Now class, I think that's it for the electric fields in matter. Tapos magdi-discuss lang tayo ng konti sa electric currents. Anong oras na? Okay, we still have time. Na class, ano na to class? Intro to magnetostatics na tayo. So, let's discuss electric currents. Di ba class, so far, lahat ng ginagawa natin, charges na stationary. Meron tayong bound, di ba? Bound, meaning nakadikit lang yung charge mo. Bound charges, tapos electrostatics, or charges in at rest. Here, yung sa electric currents, your charges are in motion. Gumagalaw na sila. Balik class, we define the current as a net charge passing through a point per unit time. Diba? Kung ang sa mechanics, velocity, position per time, sa electromagnetism naman, current ay charge per time. So dq over dt. Ang unit neto class ay coulomb per second or amperes. Now, kunwari meron tayong wire. So suppose you have a wire. With current. Let's say due to charges Q moving, let's say with velocity V. Now, itsura niyan, meron tong wire. Sa loob niyan may mga, kunwari, plus Q. Mga Q yan. Moving with velocity V. Now, let's say we let the linear density of charges be n sub L. Take note class, this is number of charges per unit length. Hindi siya yung charge per unit length siya yung number of charges per unit length. So ito ay, kunwari, 1 per meter or 2 charges per meter. Parang ganon. Wala siyang dimensions. So bali yung current mo dito, that is given by Q times the charge density n sub L times the velocity. Now, para ma-imagine nyo to, dimensional analysis tayo. This is coulomb, di ba, yung charge? Ano to? Ang n sub L, 1 per meter. Tapos ang velocity mo, meter per second. So, bale, meron kang, ano to, coulomb per second. So, siya yung current nyo kapag given ka ng ganyan. So, now class, what if hindi wire? What if meron tayong volume? So, let's consider a volume with current flowing through it. Kunwari ganyan, hindi na siya manipis na wire. So, meron kang I going in that direction. Now class, introduce natin yung current density. So volume current density. We label that as J of X. Now, definition natin class, ang J of X that is equal to DI. Take note class, ang current natin ay vector. Depende sa kung saan siya pumupunta, yung charges natin. Over dA perpendicular. So, paano nyo ma-imagine yan? Yung example natin above. Meron kang I, ganyan. Tapos meron kang, ano ang area na perpendicular dito? Ito, small area. So, small current over small area, yan yung volume current density natin. Pero class, di ba kung volume current density, dapat current over volume? So, bakit siya current over area lang? Di ba? So, note, J of X is current per area. Even though, even though it is a volume current density. Class, bakit? Bakit hindi ako pwede mag-divide ng volume? Na-imagine nyo ba class, yung itong small area, yan na yung pinakamaliit na pwedeng puntahan ng current. Kasi kung meron tayong point, hindi mo ma-define yung current doon. You need at least a small space na katulad nito para may current na pumasok sa kanya. And actually, that is the volume current density. Even though nagdi-divide ka lang ng surface area, siya na yung volume current density natin. Okay, so ano pa to? Next. So if the moving volume charge density let's say that is rho. Take note class, ito na volume charge density is rho. Take note, may density ka pero gumagalaw yung density na yon. Pero constant siya. Na-imagine nyo ba class, kapag pinos nyo to, di ba, kunwari movie yan, tapos nag-pause kayo, kung anong density niya sa isang point, uniform yun everywhere. Kasi constant lang naman yung current mo. So it's rho, and the velocity is v. Then, we have g, that is rho v. Later on, magdudwell in pa tayo dito. Pero, para ma-imagine nyo to, dimensional analysis ulit. Ano ang J? That is current per area. So, coulomb per second. So, 1 over meter squared. So, ano ang rho? Coulomb per meter cube. Ano ang velocity? Meter per second. So, bale, magmamatch yung dimensions nila. Plus, kung nalilito kayo sa units, maganda ang dimensional analysis. So now, when current flows on a surface, kanina volume, di ba? Ngayon naman suppose meron tayong flat surface na ganyan. Kasi yung current mo, ganyan yung direction. Kanina, meron tayong small area, di ba? This time naman, meron tayong small length. Let's say DL, perpendicular. Here we have a surface current density. Kanina J of X. Ito naman, gawin natin K of X. Tapos, we define that as, kanina di ba current per area? Ito naman, current per length. Even though ang tawag sa kanya surface current density, dinidivide natin siya ng length. Now again, when the moving surface charge density is, let's say sigma, and the velocity, let's say that is given by V, then we have K equals sigma V. Kanina di ba J equals rho V? Ngayon naman, K equals sigma V. Now class, let's recall that our volume current density is given by dI over dA perpendicular. So, kunwari, cross-section tayo nung volume. Let's say this is your small area. Gawin nating delta A. So, wag na nating gawing dA kasi baka isipin nyo parang point lang siya. Sabihin nating delta A yan. Tapos meron kang current dito. Tapos yung iba dyan, syempre, papasok dito sa delta A. Take note that delta A is perpendicular to the current. Ganyan siya. Etong mga to, yung mga arrow na yan, these are charges in motion. Now, suppose we let delta Q be the amount of charge. Hindi ko na class ginagawang differential kasi baka isipin nyo parang point particles. Kunwari may bulk tayo, bulk ng charges. So this is amount of charge that passes through. Delta A over, let's say, some time interval delta T. So, over delta T, yung charges na pumasok dito sa delta A ay delta Q. So, bale, J natin. So, let's say, ano to? This is N hat. N hat na lang yung direction ng delta A natin. So, class, ang J natin, that is the current, di ba? Delta Q over delta T. So, the current over the area. So, delta A. Ano ang direction niya? N hat. Suppose ganyan. Arbitrary lang na direction ng particles natin. N hat. Now class, we note that delta L over delta T, that is, ano to? V, yung velocity. Etong J natin class, ang gawin natin, let's divide that, delta Q over delta A. Tapos, mag-multiply tayo ng delta L over delta L. Tapos may delta T pa sa baba. Class, ano to? Delta L over delta T. That is the velocity. Next page na nga tayo. N hat. So J, that is equal to delta Q over delta A, delta T, delta L. Delta L over delta t n hat. Actually, class, this is our velocity vector. Diba? Length over time, direction ng particles, yun yung velocity vector mo. Tapos, class, ano ang area times length? Anyone? Ano ang area
Volume
times
po.
length? Volume. So, ang charge over volume ay rho, yung charge density mo. This is rho v. So, pinakita ko lang kung saan nanggaling itong J equals rho v. Dito yon. Now, mahalagang result to class because everything boils down to the current density. Di ba class, sa electrostatics, kapag meron kang charge density, pwede mo nang masolve yung potential and electric field. Sa magnetostatics naman, when you have the current density, pwede mo nang masolve ang potential and the magnetic field. So example tayo. Let's say meron tayong loop. A loop of, radius A. And let's say my charge Q. Positioned at Z equals 0. It spins at a constant angular speed omega. The question is calculate the current density. So now class, how do we do this? Drawing muna natin. So meron tayong, ano to? XYZ. Meron kang loop of radius A. So ayan, along XY siya. Position at Z equals 0, spins at an angular speed omega. Ayan. Now class, what is the current density of this following setup? So take note class, earlier, J equals rho V. So first, find rho. Class, ano ang rho ng configuration na to? We will use cylindrical coordinates. So this is charge Q. So Q over 2 pi A. Class, alalahanin nyo yung method ng pag-construct ng charge distributions. Dirac delta of Z, kasi position at Z equals 0, then Dirac delta of S minus A. So yan na yung ano natin, charge density natin. Ano naman ang velocity? Class, kung meron kang rotating body na umiikot at a constant angular speed omega, ano yung velocity nun?
R omega.
So R omega, di ba? So A omega. So, kasi yung R natin is A. Pero class, velocity is vector. So V equals A omega. Anong direction neto? A omega phi hat. Class, di ba? Ito yung phi nyo. Pag ganun siya. That is your polar angle phi. Tapos yung pag-ikot niya, along phi hat. So now, we get the charge density. That is rho v, or that is equal to, ano to? Q over 2 pi A delta Z delta S minus A. Q over 2 pi A delta Z, delta S minus A, tas A omega phi hat. Magka-cancel yung A. Therefore, ang current density natin, Q omega over 2 pi, delta Z, delta S minus A. So, yan na yung ano natin, current density for the system. Now, class, actually, kapag problems sa magnetism, mahirap. Ito yung isa sa pinakamahirap na step. Construct the current density. Pero class, alam nyo naman na mag-construct ng rho, di ba? Itong yung charge density na usual. Tapos alam nyo naman yung velocity. Depende na yan sa system mo. You can easily construct the, actually the, ano to? Volume, the current density. Now class, hirapan natin yung problem. What if meron tayong dalawa? So another example. Sige, i-mental nyo na lang to. Meron kang same loop pero positioned at Z equals H yung isa. Tapos meron kang isang loop ulit at Z equals negative H. So class, by inspection, ano ang current density nyo dyan? Pareho silang at constant angular speed omega. So ito umikot din at omega. Now that is
Sum lang.
sum lang. Actually, Q omega over 2 pi. Pero yung Dirac delta mo magbabago. Yung first loop, Dirac delta Z minus H. Dirac delta S minus A. Plus Q omega over 2 pi. Dirac delta of, ito, Z minus minus H yan. So Z plus H. Dirac delta of S minus A. Usually, feeling ko makaka-encounter kayo ng ganitong problem. Dalawang spinning loops. Then calculate the magnetic field. Okay. Now class, madaling example naman tayo. Kapag may Dirac delta kasi parang medyo intimidating, di ba? Suppose walang Dirac delta. So a uniform, unang uniform. So a current ay this flows through a wire. Na may circular cross section. So cylindrical wire to. Cross section of radius A. So meron kang wire dyan, radius A. Then may I dito. So the first is find the magnitude of the volume current density. J. So kanina 'di ba J vector? This time magnitude lang. So how do we solve that? Now, class madali lang to. J equals I over pi a squared. I over the area. Yun lang class yung magnitude ng volume current density mo. Direction, depende sa ano mo, kung saan tumatakbo yung current mo. Okay, class. So now, medyo hirapan natin. B. Let's suppose that J of X equals Ks, where K is constant. The question is, tanggalin ko na nga yung vector na yan. Find I. Now, class, recall natin that J equals di over dA, perpendicular, di ba? Now, di bale, that is equal to J dA. Now, ito ay equal sa, ano yung J natin? Ks. Where S is the cylindrical coordinate natin. Class, ano ang small area dito sa configuration natin? So, ano tayo? Side view. Side view ng wire. So, this is S. Now, class, in cylindrical coordinates, yung small area natin ay SDS d phi. Kasi class, di ba, ayan yung S, ito yung phi. Parang RD theta. Pero mag-shift lang tayo to cylindrical coordinates. So siya ay SDS d phi. KS SDS d phi. So bali ang I natin ay integral ng KS squared ds. So S runs from 0 to A. Tapos integral ng d phi 0 to 2 pi. Now, mental na lang natin. K A cube over 3 2 pi. Yan na yung current mo. So kung given ka ng charge density, you can find the current. Integrate mo lang. Ay, current density pala. What charge density? So now class, sige last topic na. Tandaan natin that charge is conserved. So this means that whatever flows out, let's say through a closed surface, this must come at the expense of that remaining inside. So balik class, anong ibig sabihin yan? Meron kang closed surface. So whatever flows out, so kung anong lumalabas dyan, must come at the expense of that remaining inside. Manggagaling dito. So kung ano to, may lumabas dyan, that means nabawasan to. Okay, so yan muna yung tandaan nyo. So let's recall that I actually is surface integral ng JDA. Now, this can be written as the surface integral J dot dA. So yung area vector natin na yan. 'Di ba? Yung kinukuha natin yung perpendicular component ng A. So that is the dot product. Now, let's say we have closed surfaces. So for closed surfaces, we have, gawin lang natin closed surface. J dot dA. Tapos, let's do the divergence theorem. Integral over the volume del dot J d cube x. Diba? This is your actually going inside. The charge density going inside. Now class, this is equal to the negative time derivative of the d cube x. Charge density d cube x. Going outside. Sige, para ma-absorb nyo. Itong del dot J d cube x, ito yung charges na parang pumapasok dun sa surface mo. Itong kabila naman, rho d cube x. Charge yan, di ba? Tapos, charge, time rate of change ng charge mo na lumalabas and negative nun, that is equal to the charges going inside. Teka nga lang. So, ito, Yan yung ganyan. Tapos itong kabila naman, yun yung going outside. Labas. Tapos yung negative derivative neto, actually, ito yon. So yung rate neto equals the negative rate netong kabila. Yun lang yung sense ng dalawang equations na to. Kasi kung ano yung pumupunta sa outside, at the expense yun ng kung ano ang going inside. So bale, let's rewrite that. Volume del dot J d cube x. That is equal to negative ano to? d dt ng rho d cube x. Plus yung differential natin d cube x, di ba? So bale, negative integral ng pwede nating ipasok yung derivative sa loob. Kasi d dt naman to, ito d cube x. So pwede natin ipasok yung derivative sa loob. Now, volume del dot J d cube x. Take note that the volume is arbitrary. Therefore, ito equal dito. Now we have, so therefore, del dot J, that is equal to negative partial rho, partial t. Actually, this is our continuity equation. Continuity equation. Class, hindi nyo lang to may encounter sa electromagnetism. May encounter nyo to sa fluid dynamics, sa quantum mechanics actually. Baka may encounter nyo yan. Yung continuity equation na yan. Class, I think yung second exam nyo hanggang sa topic na to. Then, this is actually our last meeting. Tapos sa susunod na session, Sir Herbert na yung magtuturo sa inyo.
So tomorrow po may klase kami with Sir Domingo?
Tomorrow hindi pa kasi yung start nyo kay Sir Domingo ay sa Friday. So tomorrow sa akin pa. Pero pahinga nyo na yon. Natapos naman natin yung coverage nung hanggang electricity. So dito yun mag-e-end. Tapos class yung exam nyo, Monday, di ba? Pinamove nyo ng Monday. Tapos yung problem set nyo, Monday na rin. Para may time kayo. So any questions, class?
Nasabi niyo po dun sa isang video na pang-5 item yung nandun. Parang pang-4 lang po siya.
Ay talaga. Sige, okay. Kung 4 pa lang, magdadagdag pa ka ng ibang question para 5 yung nyo, problem set. So sige, pang-4 yun, then magbigay na lang ako ng isa pa para 5 yung items nyo. Then,
Okay po.
okay. May iba pa bang tanong? Wala na, clear naman. Hopefully clear naman lahat. So class, yun lang sa electricity. Actually, itong buong 130, siya, medyo, di ba, napapansin nyo naman, heavy siya sa math. Pero, actually, lang siya, methods lang siya on how to solve the potential, basically. Di ba, halos lahat ng ginagawa natin, nagbo-boil down sa electric potential. Kasi once you know the potential, alam mo na lahat, electric field, so forth, so on. Now, ganun din class yung magiging method nyo sa magnetostatics. Here we have the electric potential, di ba? Electric scalar potential yung meron tayo dito. Sa magnetostatics naman, meron kayong magnetic vector potential. So, mas mahirap yun kasi vector na siya. Heads up lang, medyo mas mahirap yung magnetostatics kasi electrostatics. Pero kaya niya yan. Meron naman ako yung basic knowledge ng Laplace equation, Green's function. You can progress naman sa remaining topics ng 130. Okay. Wala nang tanong?
Sir, dalawang exam pa po ba kami sa magnetics?
Yung remaining 3 units nyo, I think 3 exams. Kasi 2 units per unit, 1 exam. So, 2 sa akin, 3 sa remaining topics. Madali lang yun. Kaya nyo yan. Okay, wala nang tanong?
Final exam ba kami?
Depende, pag-uusapan. Kung kailangan nyo. Okay, so wala nang tanong. That's it. Then, I'll give your exam sa Monday na lang. Okay, dismiss na tayo.
Salamat po, sir.
Okay, thank you.
Thank you po.
Hey.
Bye.
Thank you, sir.